Bismillahirrahmanirrahim. Our today's objective is to perform experiment number 12, which is to study the V.SK-80386 and LCD mode and LED lamp mode. V.SK-80386, and this is the name of the trainer model number of the trainer on which we're gonna perform LCD mode and LED lamp mode. This trainer is easily accessible in NFCIET microprocessor lab, but over here we have to do it orally, and we need to understand first of all what is microprocessor and how this trainer gonna perform these two mode of LCD mode and LED lamp mode. So let's start with the microprocessor, or with the explanation of microprocessor. A microprocessor is sometimes called a logic chip. Over here, a microprocessor is sometimes called a logic chip, is a computer processor on a microchip. The microprocessor contains all or most central processing unit function, and it is the engine that goes into the motion when you turn on your computer on. So basically microprocessor would act as an engine for all the instruction you give to your computer, or it contain all the basic functionality of a central processing unit. So basically the microprocessor act as an engine which run the whole system or whole scenario what's going on in your computer. A microprocessor is designed to perform arithmetic and logic operation that make use of small number holding areas called registers. So microprocessor does have register. We know what are the registers. Register are small holding areas, or small you can say that the small storage areas. Whenever we perform any arithmetic or logic function in microprocessor, whether in the form of logic operations, whether in the form of arithmetic operation, the result gonna be stored in the registers. Typical microprocessor operation include adding, subtracting, comparing two numbers, and fetching number from one area to another area. So these are the typical or the most basic functions of a microprocessor. These operations are a result of a set of instructions that are part of the microprocessor design. So basically these instructions are fed into the microprocessor design. So now we will talk about V.SK-80386, and we will talk about the trainer. This is the trainer model number, and the 80386 microprocessor is a full 32-bit version of earlier 8086 80286 16-bit microprocessor, and represent a major advancement in the architecture, switch from 16-bit architecture to 32-bit architecture. So previously 8086 and 80286 were of the both were of 16-bit architecture. They perform on 16-bit functions and operations, but the 80386 microprocessor is the advanced version, and it is operate on 32-bit operation or 32-bit architecture. Along with this larger word size are many improvement and additional feature is already involved in this model trainer. The 80386 microprocessor featuring multitasking, memory management, virtual memory with or without paging. You all know what is paging. Paging is a one message broadcast to everyone. This is known as paging. Software protection and large memory system. So other than logical and arithmetic operation, 80386 can also perform multitasking, memory management, virtual memory management, software protection, and a large memory system. All software written for the early 8086, 8088, and the early 80286 are upward compatible to 80386 microprocessor. So all the software that work came across before 80386, they have the upward compatibility toward 80386 microprocessor. The amount of memory addressable by the 80386 is increased from 1 MB found in 8086, 8088, and 16 MB found in 80286 to 4 GB in 8086. 386. So basically 80386 has a memory of 4 GB, 80286 has a memory of 16 MB, and 8086 and 8088 has a memory of 1 MB. So these are the memory distribution over the generation of microprocessors. Uh, the 80386 can switch between protected mode and real mode without resetting the microprocessor. So 80386 has a flexibility that it can switch from protected mode to real mode. Real mode, which we perform real-time operation. Protected mode, for example, protected mode operate in virtual memory. For example, the function of paging is operating in the protected mode. So real mode and protected mode, these are the two basic modes of any microprocessor. The 80386 microprocessor has the ability to switch easily between real and protected mode depend upon the type of instruction it is given. Switching from protected mode to real mode was problem on 80286 microprocessor because it required a hardware reset. Previously, 80286 had a problem in switching between real and protected mode because it required a hardware reset button for this. But this problem is resolved in now 80386 microprocessor. Now we will discuss about the data type of 80386 microprocessor. The following data type are directly supported and thus implemented by one or more 80386 machine instructions. These data types are briefly described over here. Bit Boolean value, bit field group of up to 32 bits, and bit string group up of 4 GB in length. 8-bit integer, you know that 1 byte is equals to 8 bit, either in signed or unsigned. This is a range of signed bits and this is the range of unsigned bits. 16-bit integer, either signed range, this is a range of signed bit and this is a range of unsigned bit for 16-bit integer. 32-bit integer, either signed range, this is the signed and unsigned range of 32-bit integer. Again, this is a signed and unsigned range of 64-bit integer. Offset a 16 or 32-bit displacement referring to a memory location using any addressing mode. So you all know that we have already discussed offset in addressing mode. This is a displacement of the 16 or 32-bit number which is added into the base address to go into a memory location or to fetch any specific entry from the memory. Pointer, a 16-bit selector together with 16 or 32-bit offset. Pointer is something which is point toward memory location, some specific memory location. So we can be seen as it is a selector, 16-bit selector, which together operate with 16 or 32-bit offset address. Character, 8-bit character code, string, a sequence of 8, 16 or 32-bit word up to 4 GB in length, or BCD. You all know about BCD codes. Decimals 0 to 9 presented by unpacked bytes, packed BCD, 2 BCD digit in 1 byte. These are all the data types. These are all the data type of 80386 microprocessor. So the program, here we have a program for LCD mode. After this program, what we're gonna see? We're gonna see a 386 on dot matrix screen of this trainer V.SK-80386 model. First of all, reset button. First of all, we have to press these all buttons one by one. First of all, press reset button, then press 2, then press enter, then press go, then 6 0 0 0, again then colon 1 3 0, enter. Then the output gonna be see 8386 on dot matrix screen of V.SK-80386 and trainer model. So this is our program 1 for LCD mode. We have seen 80386 display on the dot matrix screen or LCD screen, whatever you say. It is actually a dot matrix screen, but the program is represented as LCD mode. The next program is reset. We have to press first reset, then press 2, then enter, then we have to go to press register, then again double enter, then enter 9 7, then 4, then enter, again This is 874, enter 580 dot, then tetra 5, then enter. This output, one thing you should keep in your mind, that all these button is available on trainer. You have to press this button simply by seeing the program. The output of this program would be LED glow, alternate pattern, alternate LEDs glow, or you can say that LED is glowing in an alternate pattern, one after the other. So this is simply the two program which is we performed. If for example, if I have to conclude this lab, I will conclude like this: that in this lab we have studied about V.SK-80386 and model for LCD lamp and LED lamp mode. For LCD mode, this is not lamp over here, this is mode. For LCD mode and LED lamp mode, we have also implemented, we have first we studied about LCD mode and LED lamp mode and implemented. This is again, we have to write it mode over here. So basically, this is the objective, and we have achieved the objective of today's lab. We have studied V.SK-80386 trainer, and we have also studied about 80386 microprocessor. This is the upgraded version, and we also discussed the previous microprocessor like 8086, 8088, 80286, their RAM, their memory, and their architecture. The upgraded version 80386, his memory, his architecture, we all study about this 80386. But we again, after the second part, after first part, in second part we discussed model, the trainer model V.SK, and the program which we will operate on the trainer, and the output we will show after first program is 386 on dot matrix screen, and after second program we have seen LEDs glow by alternate pattern, which is present on the V.SK-80386 and model, trainer model. So hopefully this would be a good guide for you guys, and you hopefully you enjoyed it. Thank you. Any question we will discuss on a live session for sure. Okay, thank you.